To lay good foundation, earlier the better. In the nearest future, you will be one of the leaders. So we pray, amen. Oh my daughter, you should be ready to lay good foundation. Earlier the better. In the nearest future, you will be one of the leaders. So we pray, amen. To become a leader is not very easy. To become a man is not daily work. Everybody's ambition is to become a leader, is to become a big man. That is amen. Oh my daughter, you should be ready to lay good foundation. Earlier the better. In the nearest future, you will be one of the leaders. So we pray, amen. You should be ready to lay good foundation. Earlier the better. In the nearest future, you will be one of the leaders. So we pray, amen. To become a leader is not very easy. To become a man is not daily work. Everybody's ambition is to become a leader, is to become a big man. That is the struggle. So my daughter.
Today's lecture on building skill acquisition has the intention to transfer the knowledge and the skill of building a house to the present students and future generation of Nigeria. This building skill acquisition will enable the students and the young generation of Nigeria to have the skill that will equip them to meet up with the economic challenges in the country. Because when a one might have acquired the knowledge of building skill acquisition, that person can be able to employ himself, can be able to employ his or herself, and fit into one industrial aspect of the nation, because it is obvious that most people do not have the opportunity to pass through the higher institution, and some of them so having no opportunity to pass through the higher education in the country as an excuse to their unemployment. But after today's lecture, they will know about building skill acquisition, and anyone who watched this lecture will know how to construct a house. So today, I will tell you people how to start the processes in building construction. I will first and foremost introduce myself. I am Oluka Ifeanyi, a graduate of Enugu State University of Science and Technology, ESUT. For a one to start building construction, that person will pass through site investigation. Site investigation has to do with proper observation of the site location, to know the type of soil, to know the size of the plot, which that person cannot do in the isolation of the survey. For you to construct a building, you will propound your survey plan and consult architectural and structural builder to come and draw the building plan for you. After the drawing of the building plan, you will take the building plan to local government for approval. When you get to the local government, they will now approve it. After the approval of the drawing, you are now ready to build. But there are some vital information which some builders do isolate in their building construction. Those information are referring to soil type, soil, because soil is the out layer of the earth surface. It is a loose material get from the waddling of rock. The foundation type depends on the type of soil in which the building will take place. In this sense, it will now lead us into the research of the various types of soil. After identifying different types of soil, we will now move to different types of foundation and how to use it in each type of soil in order to achieve a suitable building construction and adequate building construction in the nation, in order to eradicate the collapse of building, because it's obvious that buildings are collapsing here and there. People suffering from so many barriers in building construction, especially the clients. During this lecture, each and every one of us will be able to observe the consequences of incorrect building practice in the country. But after today's lecture, you will know about the subsoil and the topsoil and how to suit a foundation to each type of soil. So please, I will make a move to show you the type of soil, but we will start from the swamp area, because most people will use the type of foundation which they're supposed to use on a sandy area. They use it in a swamp area, which will cause betrays in wall and the betrays in building construction. Thank you. Yes, as you can see, this is an example of swamp area, and this swamp area required a specific type of foundation. It's not any type of foundation that you can use here. There is a specific type of foundation you can apply in a swamp area. So you students have observed this type of soil as a swamp area, and it's not a proper soil for building construction. But it can be adequate when you make use of the normal foundation required for this type of soil. Now, for example, for those who are not qualified in building construction, those who do not pass through the necessary practice in building construction, I will show you the example of what they have done, which resulted in negative consequences. Now, look at this building for you to observe what I'm talking about. I told you that I will show you the consequences of improper foundation type in building construction. Look at this wall. You can see a crack. This crack in this building is as a result of inadequate foundation use. The builder that constructed this building do not know that he's supposed to make use of large foundation in this type of sticky clay soil, which is associated with swampy area in this place. And as a result of this betrayals in this world, the owner of the house, the occupants of this building, have run away for his dear life. And because there are so many other inconveniences that may associate if the engineer do not know what he's doing. So take a note. So listen again. This type of soil is not very proper. It is not very proper for building construction because of the earth movement, the land movement. The land is expected to vibrate at least once in every year. And when a builder have constructed a house in this type of area, after the rainy season, if the builder did not make use of the normal foundation type that will suit this soil, during the movement of the soil, the building will start the cracking, just as the example of what I have shown you in this building. So take note, we are now migrating to different types of foundation, which I will now tell you the different types of foundation and how to make use of them towards each and every type of soil. So, as I have been careful of swamp area, so shall you be very careful about this type of soil. But most people who do not know much about soil type don't know the negative impact of making use of incorrect foundation in construction in this type of soil. Thanks. In this lecture, we will talk about foundation because foundation is the base of any structure. Without a firm foundation, the structure cannot stand. Foundation should be designed in a way to transmit the load of the building to the ground level, because without a firm foundation, no building will survive. And foundation is being determined by the type of soil and the type of structure that we are about to construct. As from now, I will lecture you on different types of foundation and tell you how to arrange such a foundation type. But we have to start with raft foundation. Raft foundation. If you listen proper, you will know about the raft foundation. In this lecture, that we discuss about raft foundation. And here, looking at the foundation trench, you see this place have been branded. After this branding, next comes the raft foundation, because the raft foundation is a type of foundation that consists a raft reinforced concrete under the whole building with a compressible ground, such as a very sticky clay soil. Now look at on the application of the flat foundation. After the branding of the foundation trench, next comes the bar. This is a bar. After creation of this bar, you will cover it with a concrete. You make sure that the bar will be in alignment of the block. You use the block nail to achieve the standard placement of this loft wall. This is a very good example of a loft wall. In building construction, as I have shown to you, the sticky clay soil, which is associated with the swamp area. In that swamp area, you make sure you make use of this type of raft foundation. This is a very example of a raft foundation. Some people call it grand beam.
If you don't know why they this time, it's more you go pay. I'm going to enter your video.
In our discussion or lecture on the raft foundation, I told you after the beam, after the ground beam, after the branding, you brace the beam, which I have shown to you on that branding, in accordance with the line, in accordance with the block line. After the block line, you place your beam and cover it with a foundation footing. That's all about raft foundation. Okay. Furthermore, there are two types of foundation. There is one called a white bed lath foundation. That bed lath foundation is done by bringing this bar, come in. Placing them at the required aspects of the building, of the foundation. Just this is a typical example of a white bed lath. This thing now is expected to cover with a proper, well mixed foundation footing in order to achieve a suitable white bed lath. The other one I showed to you previously is known as white raft. Thanks. I told you about raft foundation, and this is a typical example of a completed raft foundation. But in a situation where you don't want to extend the height of your raft foundation to this extent, you are expected after the placement of that bar, which I have shown to you previously, you will cover it with a foundation footing. Foundation footing of a minimum of 225, a minimum of 225 foundation footing. But at this stage, this one now is ready to be laying block upon. No type of block that you lay here that can ever crack on earth, because during the vibration of such a sticky clay soil, this thing now will now resist the soil movement and will never allow the block to crack. That's all about raft foundation. Take a note on raft foundation, and because it is a raft foundation is designed to a sticky clay soil that may be experiencing various movements in gravitational of waves. Yes, I told you about the raft foundation, and we knew this structure as a raft wall or a pie foundation. You can see it is behind the stream or a river. This shows that any building that constructed here without proper reinforcing the foundation, you see that building will collapse. But I will tell us that in a situation like this is how to start the construction of a raft wall or a pie foundation. See how this thing has been constructed. This spacing of bars is being determined by the expected thickness. If you expected to have a thickness of 225, then you will just space it here and get it from this dimension. You can see. But if you expected a thickness of 150 mm thickness, it can be determined through the use of this bar. So this is how we can achieve a pile foundation or a raft foundation that can be suitable to the type of shrinkable clay soil like this or behind this river. Everyone can observe how this thing is being structured, because in the continuation of this program, I will show you the completed aspect. For you to know, by the time I will show you the completed aspects of this type of foundation, you will know how this thing, you will know how it has been created, because this is the beginning of such a foundation. After excavating it to a very high depth aspect, and you will see how this thing is being processed. You can see, I told you about this type of foundation, and I told you the beginning of this type of foundation. People can call this a retaining wall. You can call it a raft wall. But what we have to, the intention of showing you this thing is during our continuous practical assessment, you will know how this thing is being created and the purpose of its creation. I told you about how to structure it and show you the practical aspect of it, but this is a completed part of the pipe and the raft wall, or I call it pipe foundation or retaining wall. This thing is being structured in order to prevent this wall from being betrayed. So take a note about this type of foundation. told us that we will be discussing about different types of foundation. Now, we talk about strip foundation, because a strip foundation is type of foundation that bear concrete under the load bearing wall. As you can see, this is a typical example of a strip foundation. This is a strip foundation, and I told you that it bears concrete under the load bearing wall. This is the concrete, which is called foundation footing. This is a foundation footing, and in a strip foundation, during the excavation of this trench, you will see there is a step up here. The reason to this type of step up is because the ground is no longer level. Take a view and observe the nature of the sloping of this land. You will understand that this level is no longer at the uniform level. That is why they apply this step up of 225. And how to determine this step up of 225? During your excavation, when you note the differentiation in level, that is when you will now get a 225 height block. You bring a block. During the excavation, when you note a change in ground level, that is how you determine the stepping up of a foundation trench or foundation excavation. In a strip foundation, when you note this valley in level, you just bring this type of block and place it during the excavation. This will enable you, this application will enable you to achieve a standard level of the building. If you omit this step up in a slope area like this, that will lead your building to a slopey. The building will be slopey to people's sides, because it will no longer achieve a suitable level and the standard level. But in a way that we have applied this step up of 225, because why it is a step up of 225 is because if you use your tape and measure from here to this height, it is a 225. And when the next block is coming, it will tally with the same level. And by the time you put another block wall on top of this one, you will get the level of this one. Then it will be at accurate level. What I'm trying to say is that this is a type of foundation called strip foundation. It is applicable to a slope area and to a normal land. So take a note of this type of foundation trench and foundation excavation. Now, in excavating this type of foundation, if you are making use of a block of 225 size, you are expected to get the 225 away from the block. For example, you can see how this thing, well, in the foundation layout, I'll tell you about foundation excavation. Just take a note of strip foundation, because people might have been hearing about strip foundation, raft foundation, pad foundation, and pile, but they cannot identify it whenever they see it. That was the intention of I being here, to show it to the students so that they can know about these different types of foundation and know that the depth of foundation is not the foundation but it's just excavation. But knowing these things, you can now make use of strip foundation. And I told you that we make the type of soil determines type of foundation. So in continuation of this lecture, you will know more about foundation and their determinants. Thanks. This is a typical example of pad foundation. Pad foundation is a type of foundation that is being structured by inserting the column base, and the column base will come and exceed the natural ground level. That is why this thing you are seeing here is a typical example of pad foundation, you can see you can use this thing to achieve a standard high level or height. So I told you that part foundation is a type of foundation which you will insert coal, and on top it will be a beam. This is the beam to support whatever construction you want to do, and it is highly economical. It is economical in structural arrangement. Using the part foundation, you can use it to achieve a standard level where there is a high slope area or where there is a flowing river. That is advantage of part foundation. You can see the structure bears a residential area at the upper side of it as a upper floor, but here it's totally empty. That is to say, this is a part foundation. You can use it to achieve your aim in a place where there is a high hill or a mountain to achieve a standard level. In the sense that when you have inserted this pillar, this column base, if you insert this column base, and at the other side, maybe the other side is there is a high slope area, you can have the other side excavated and achieve your intention. So that's all about part foundation. In the continuation of this seminar or this lecture, you will learn more about part foundation and their uses. Thanks for listening. This is another example of part foundation. Another example of part foundation. I told you that part foundation is a foundation that bears a column base that is brought up and the bear assistant beam at the upper level in order to sustain the block wall that will be imposed or that will be laid on it at the upper level. That is why it's constructed this way. Take a very good observation of part foundation. Take a very good observation of a part foundation anywhere you see it. You can view it proper to know about part foundation, because most of you might have been hearing about part foundation, but you cannot identify it. Part foundation. Okay, now we want to discuss about setting out of a building. And in a setting out of a building, there are certain things that accompany the setting out of a building. But we shall first and foremost let everyone know that in building construction, before one can become a builder, that person will know how to read tape. So for that reason, I will explain how to count tape. If you look at tape, you start counting the tape by 25 mm. And if you want to convert 25 mm to inches, it will be 1 inch. But 50 mm, conversion of 50 mm into inches, then it is 2 inches. While 75 mm is in the conversion to 3 inches. And 100 mm is regarded as 4 inches. So, but let me make it clear to each and every one of us to know how to count the tape. When we talk about 50 mm, look at the 50 mm here. We talk about 75, look at the 75. But this is 100 mm, which is regarded as 4 inches. You count when reading this this article written with a lead object. You will know that this thing is counting on millimeter, because in most drawing of a builder, they make use of millimeter and meters. So here is millimeter. Look at 300 millimeter is 1 feet. While 1000 mm is about 3 feet 3. So that's how you continue to count. When you talk about 1200, which may be called 1.2 meter, it is about, look at it here, 1.2 meter. So what I'm trying to do is that each and every person who wishes to be a builder must first and foremost learn how to make use of tape. That is my intention. But when you hear about 3000 mm or 3000 mm, it should come to your mind that we are talking about 3 meters. which is about 9 feet. 9 feet, 1, 2, 3, 4. Look at how to count the inches. 9 feet here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means 3,000, which is 3 meters, is about 1 feet 9. So that is how you continue to do it until you come to a standard measurement of a loom, which is 3,600. That's all about counting of tape. Because from now henceforth, we will be migrating to setting out. In setting out of a building, that's what is known as a site plan. That everyone who wishes to be a builder will first and foremost learn how to count tape. Because there's nothing you can do in building construction in the isolation of tape, which is the vital tools. It is a vital tools in building construction. And when you're looking at architectural drawing, you will know that they are making use of millimeter and meter, which they may say 1 meter or 1,000. If you have such a terminology, look at, you should quickly rush to this side, and you will know that 1,000 is this thing. Looking at upper side, we are counting on feet. You can count in inches, you can count in millimeter, you can count in feet and inches. But builders make use of millimeter and meter in Nigeria and most part of the nation. So please, for you to be a good builder, you should first and foremost learn how to count tape. Because the tape starts from 1 inch, which is 25 mm. You move to 2 inches, which is 50 mm. It moves to 3 inches, which is 75 mm. You migrate to 4 inches, which is 100 mm. It moves to 8 inches, which is 200 mm, and move to 300, and move to 1 foot, which is 300 mm. So shall it continue until it gets to the standard measurements of some looms, which is 3,600, which may be called 3.6 meters. And the measurement of a window in building construction most at times is 1,200, which may be regarded as 4 feet. So please, it is very, very important that every student who wishes to be a builder will first and foremost learn the counting of tape, so that you can help you to become what you want to be in building construction. In building construction, you come across the site plan, which will tell you which is the survey plan. It will tell you the access load and the proper position of the building and the spacing you will give from the fence and the access road to the plot. That is the importance of site plan in building construction. Taking a look at the site plan now, you will observe that here is the access load which I'm talking about in this site plan. The access load in the site plan. Here is the access load. Now, here is the beacon of the owner of the land. Here again is the beacon of the owner of the land. And here is the beacon. Here is the beacon. Looking at these lines, it is telling you that from here to here is a beacon, and from here to here is a beacon, and from here to here is a beacon. Looking at this thing, you will know that this is an entrance into the building. This is entrance into the building. This sign here is telling you that this is the gate leading into the compound. When you come into the compound, look at the main building, and from the fence we get 2,400, 2 points away from the fence before we can get our main building. And from this part towards the gate side, we get 7,900 from the gate away. And here again, from this back side, we get 2,400, making it square. Now, here is our main building. Every construction or setting out you will do will not exceed this dimension here, this dimension, which is the main building. That means from here to here is 19,000, which is the size of the building. From here to here is 19,000, which may be called 19 meters. And from here to here is 19,600 mm, which may be called 19.6 meter. So that's all about the site plan. Going to the section of the building. The section in a building construction will tell you that is where everything, most things about the building which you want to construct or the proposed building have been detailed. That is where you get the roof materials, the wood, the hardwood that may be necessary for the construction of the building. That is all about the section. And the section will tell you the thickness of the oversight mass concrete that is required, and tell you how to place the hard core, and as well tell you how to do your sand screeding floor finishing and the thick mass concrete foundation footing and the size and the height of the building. But there's no need of wasting time in this section, because when we be talking about the roof aspect, we will talk about the wood and their requirements in the building construction. Without wasting time, a floor plan of a building. This is a floor plan of a building. Every builder or anybody who wishes to be a builder, I told you earlier that we are embarking on the setting out processes right now. And for you to achieve a standard setting out, looking at this floor plan, we are telling you that we get the overall dimension of this building before you set out your building. Now, looking at this veranda, it is dimensioned at 1,500, and this room, including the wardrobe, is dimensioned at 3,900, and this one, this master bedroom toilet, is dimensioned in this area at 2,400, and this room is dimensioned at 3,900. So what we are saying is that if you wish to get the setting out of this building, you have to add all these things together. You add the dimension of this veranda, dimension of this room, dimension of this toilet, dimension of this bedroom again. After adding them together, which means 1,500 plus 3,900, 3,900 plus 2,400 plus 3,900. After you have gotten this dimension, then you now calculate, because there are different types of block thickness, but here we are making use of 225 block. We have to add this 225, which is this wall, add this 225, add this 225, add this 225, and add this 225, and add it together to the overall dimension which we had arrived from the calculation of the room and the toilet, and use it as the overall dimension of this side. Now, look at these lines. You can see this is number 10. This number 10 here is telling you there is a wall here, which is known as a grid line. This is called the grid line. When you take a look at this, you will observe there is a wall here. This is telling you that in your setting out, on your profile, you will indicate all these numbers and make sure they did not omit. Never omit them. Looking at the grid line here again, number 10, you can see the wall of number 10. This grid line is telling you how this thing is going, and you find out there is another wall here under that grid line of 10. So please, after calculation of this side, you come to this side. Looking at this staircase and this staircase, you will observe that there is a recession here. There is a recession, which means this place is bigger than this place. Since this place is bigger than here, you have to start your calculation from this side. Whatever overall dimension you realize from here, it will be sufficient for this building construction in a setting out, for a proper setting out. Now, you have to add 3,600 plus 1,050 mm and 1,350 and 3,000 mm, which is 3 meters, if I may say, and 1,050 mm and this 3,525 mm and 1,800 mm. After adding all these things together, you will now add the block line again. You can create this block line, this 225 plus 225 plus this one here is 225 plus 225 plus 225 plus 225 plus 225 plus 225 and 225. You add them together to the overall dimension which you have realized to give you the appropriate overall dimension for this building, which in order to realize the main building which I have shown you in the site plan, which will guide you during your setting out in order to obtain a proper squared house. After this, in building construction, the next stage is the setting out, because we have now achieved the calculation of the main building dimension. Getting the overall dimension here, which is 16,875, and getting the overall dimension here, get them together and add all of them. Use your square, use your tape and every other thing to make sure you achieve a stable squared building. Now, I'm going to the field to display all I have told you about setting out. By the time you'll be looking and observing everything properly, you will know how to do a setting out in building construction. Now, we are going out for the setting out. I told you that in a site plan, you will have a fence. So this slope now is regarded as our fence. Looking at it, looking at this square lobe, you will know that it is our fence. But in order to achieve the main building, to get the main building, you will get what? You will get the dimension. Let's for instance, we get 1,200. You get 1,200 mm from here, from the fence. 1,200 mm from the fence, and this way you get 1,200 mm for the fence. From the fence, this is our block peg in building construction. When you are doing your setting out, this will serve as your block peg. To get the overall dimension for squaring, you put the tape, your measuring tape, in this block peg, and to load down the tape to get your overall dimension. My dimension is 16,000 mm, which is regarded as 16 meters. You load down your tape towards this side to get the overall dimension which you are looking for. Here may be regarded as this 16,000 mm. Then if you make sure it is here in a straight line, the next thing is to get the same thing you got from this side in order not to make mistake in your squaring. You get the 1,200 from here. You get to 1,200. From here, to make sure it is in a straight line for squaring. And you will strengthen your tape. You make sure there is no mistake when doing it. Get your block nail for squaring and put it here for proper building squaring. Over. In order to achieve a proper squaring of a building, this is how to achieve the square. Since we have tethered the lobe, the other side, and this edge, it is required to be squaring it until it become properly square. in order to achieve a standard setting out of a building. Okay. So once we get it properly squared this way, yes, it's okay. It is now well squared. The next thing you will do is to ask the person to hold on and get another peg in order to make sure it is properly squared. You test it again and know if it is still square. If it is still square, then you move on and go towards the end. When you are going there, don't forget to go with your tape in order to get the overall dimension of this side. Move on to get the same overall dimension. If here is the overall dimension, you're expected to tether your rope there. Over. If you note that this thing, your peg is bending, you just hit the ground for it to come to the proper way, for the proper position. Then the next thing is now, you recheck your measurements to check if it is still